guys, these are going to be the notes for Thursday. I guess it'll be what, the 11th, and we are going to be in our digital notebook, but wasn't able to get it all created at the same time. So what you're going to need to do is head into Schoology and go to Digital Notes 4.3a. And it's going to be separate for now. We'll make it all one file someday next week when we're kind of getting everything together for a quiz. So you just open that, and it says Stu because the last name is Dent for student. And it'll open you your own one of those. The other thing I want you to open is your My Proofs and Reasons page. And we're going to update that, all right? I suggest you do an edit. Select all, make it all bold and all the same font. I like Alada. And then, make it as big or small as you want it. And just scroll through here and update. We did vertical angles in class, so that should be on there. Alternate interior popped up yesterday, so you'll probably need to type that. Reflexive is old. Side, 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 you should probably type one of the 5 ways to show that 2 triangles are congruent. And then when you're done typing that, and again, just pause and play as you go, I would copy it. And yesterday, we did this one, side angle side, and today we're doing this one. So there's going to be 5 ways of showing or proving that triangles are the same. And after today, we'll have the first row down. Okay. Definition of a midpoint we used in our proof yesterday. And that is when we are given that a point is a midpoint, we know that the lengths of the sides on both sides of that midpoint are the same. That it splits it into 2 equal pieces. Third angle theorem is old. At the beginning of the hour today, we did a proof from yesterday's homework where we used the fact that all right angles are congruent. Corresponding angles we haven't used yet, but it kind of is a tool sometimes if you're given lines are parallel. It hasn't popped up yet, so when it does, we'll discuss it. Yesterday, we said that if something, I asked you what bisect meant, and you guys said it means to cut in half. And so we said, well, if we're told that something bisects an angle, we know that we get to steal 2 angles because it cuts it into 2 equal pieces. And a reason that we put for that is definition of bisect. And lastly, perpendicular means we meet at right angles. All right, so we have a good chunk of this should be done after today. And again, pause, rewind, you do what you need to do, but I would like it if yours was about as neat as mine, or I've been creeping on you. Some of yours even look better. But take the time right now to make that, for lack of a better word, pretty. And then we're going to get this workflow going. And this is for our proofs. Like, what do we do when we're writing a proof? And we're getting really good at them. We're not great yet, but we're really getting good. I'm 100% confident that you guys all know that we need to rewrite that given. Whatever was given to us, we need to write that down. And we also need to kind of do what I call absorb it. What did they give me? Did they give me a side and an angle? Did they give me that 2 lines are parallel? Maybe I steal some alternate interior. Did they give me that M is a midpoint? Oh, I get to steal some sides. You need to do what I call kind of absorbing that given. The next thing you do is you do what I call add your brain to get unmarked or ungiven, if you like that better, sides and angles. And then we should say congruent using the reasons above. So if we have 2 triangles sharing a side, bam, we're going to say it's congruent to itself by the reflexive property. If we're told something's bisected or an angle gets bisected, bam, we're going to steal 2 angles with our brain by using definition of bisect. Okay, then we are going to be deciding if in the proof it says that we're getting triangles congruent. So I'm going to write on here, which is sections 4.2 to 4.3, or parts congruent, which we haven't done yet, but we will in 4.4. So let's add that on there. To know that you look at the proof, you'll know what I mean after we get to 2.4, but when the proof or the when we are trying to prove triangles the same, we know we need to end in either side, side, side from 4.2, side, angle, side from 4.2b, or angle, angle, side from 4.3. Also from 4.3 is going to be angle, side, angle, but one of those we won't get to today. But those are going to be, and I think we should highlight those, triangles congruent. I'm going to do it in that same color, that purple, because that'll kind of help me gravitate towards there. So if it says prove triangle ABC congruent to triangle PDQ, I know my proof needs to end in one of these four. Okay? So let's go focus on our new one today. And again, pause, rewind, take a break, get that all filled in nice and neat. When that's done, we're going to hop on here and do 4.2b. We're going to use angle, side, angle triangle congruence. You can probably guess that we are going to abbreviate that ASA. I think I want to highlight that though in a yellow to make it stand out to me. So we're going to be doing side, and I like to sometimes type in here included angle side. So angle, included side, angle. That's today's task or I can statement. What method did we use yesterday? We did tab, 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 side, angle, side. So we had two sides and the angle smashed between them. Today, we're going to be trying to get two angles and the side smashed between them. Let's make that look a little prettier. Let's go here and here and maybe make it a little bigger. Let's start kind of making these a little bit pretty so it doesn't take us so long next week. What were some of our main, whoopsie daisies, what were some of our main reasons that we used? Well, you better be comfortable with reflexive after the amount of times you guys responded to me about reflexive, right? And that deserves to be highlighted. Reflexive is huge this chapter. When we share a side, and today we're going to be using it for when we share an angle. Another big one for stealing angles, and I call these kind of like the hammer and the screwdriver in your toolbox. They're used on almost every proof, is the vertical angle theorem. Then we have a couple definitions that have been popping up. Definition of a midpoint. What does it mean to be a midpoint? You're in the middle, so you split it into two equal sides. We also had definition of bisect, which means you split into two equal pieces. So those words triggered us to make a statement about sides or about angles. So let's highlight those maybe in pink. They're still there today, but we're going to talk about a couple new ones as well. And again, pause if you need to, but we're going sort of self-paced today, so you can just relax, don't worry about keeping up, but make sure you're listening. So it says another way to show triangles are the same is to get the side included side angle. So we're going to be calling that, angle included side angle. Let's make that a capital S. Let's highlight that. You don't have to, but it sure is going to help you. You'll see on your quiz next week if you've got everything ready to roll. So angle, side, angle. So down here, I have one where I was given everything. This is the kind right here on the left that I've clicked on where you say, thank you, Mrs. LaRue. Because I didn't have to work or think about anything. I've got an angle A marked the same as angle D. I've got angle B with the double arcs marked the same as angle E. And I've got the side linking them marked the same with those single dashes. I just am going to stop and go down here and make a congruent statement in here. What can I say angle ABC is congruent to? Again, match those parts. A has a single arc, it goes with D. B has two, it goes with E. C doesn't have any, it goes with F. And now our new reason was we had angle, single arc, included side with the single dash, and then angle, double arc. If I traveled around there and said them, I'd go angle, side, angle. So that one, I go thanks. Now over on this one, I've got this double runner here, and I added that, right? Right here, I don't have angle, side, angle. I have angle, angle, side. I'm not saying that's a thing. Not a thing. I'm saying it's not a thing today. So I would need some more information to make this angle, look at the purple one at A, included side, so walk along the one squeezed between them, angle, the one at D. Either they'd have to be marked or given, or maybe, let's type in right here, to get those sides the same, maybe I could tell you BD bisects AC. Okay, splits it into two equal pieces. Or I could say D is the midpoint. So type that in, of side AC. I don't like that black on the green. So let's put that in quotes. If I told you that, then you can say, and that's making it nice and big. It didn't say that. But without something more, I can't go angle, side, smash between them, angle. So I like my Alada. You kind of are getting my favorite fonts here. I do have a favorite font. Does that make me a nerd? If I was told that it's the middle, and technically I should have a segment bar over that, then I can say, all right, I'm going to go grab my line tool. Now I have this side. That's Command Copy, Command Paste. Congruent to this one. If I had to supply a reason, I would say by definition of a midpoint. So now that I was given some more information, so you know with the worksheets it says, is there enough information to prove these are the same by angle, side, angle? The way it initially was a no. It went angle, angle, side. But then I said, hey, D, you're the midpoint. And then your brain could say, all right, we're split into these two equal pieces right here. So now I can write that congruent statement and say that A, B, D, the one on the left, is congruent to, and I challenge you to pause and write it yourself, C, A and C have single arcs, B, D, also by angle, side, angle. Okay, so sometimes you need to be told more information, and here's a case in point to that. It says, what additional information would you need in order to be able to state that these guys are congruent by angle, side, angle? Right now I have an angle at F and an angle at B and a side. The side has to be smashed between my two angles. So I know that I'm going to need to get, and I like to do these little circles here because the arcs are kind of hard to draw. I'm going to put a little circle there, and I've been dumping pink paint in it. I know I need to get that angle in there at E congruent to the one in here at A, because I don't want to go angle, angle, side. I want to go angle, side, smash between them, angle. So I would need angle, and it's legal because it's only one letter there to say angle E congruent to angle A. I don't like that notation. You should know why. I did it on purpose. It's an angle, not a segment, right? Oh, this one says the included sides are. Sorry, I didn't read that question. Let's go back up here and let's type in this box what additional piece we need. All right, I like my favorite. Let me get a nice color. I hope you can't hear my washing machine churning around in there. But we would need angle E to be congruent to angle A. It's kind of small. Let's pump it up. Pump it up. Pump it up. There we go. Then we could go angle, side smash between them, angle. So angle, side, angle. The included sides would be considered FE, and I took the bar off it and I don't want to go put it back. So FE, and what other included side is there? Just for vocabulary, AB. Those are my included sides. They should have bars over it, but like I said, we'll go get all that cleaned up. So, back to an oldie but a goodie. What property or reason did we use to say that when two figures share a side, they're congruent? And we said, well, when it's itself, that's called the reflexive property, right? And it's coming back. I'm going to shorten that side up so it'll fit up there. You can do the same. Again, pause at any time to make it pretty. We've been really good. You guys have been really, when I say what property is that, I hear unanimously right now. Reflexive. You're really good at vertical angle theorem. That makes my heart happy because those are the two most important. But we haven't used this reflexive property, so let's copy it and paste it. And let's shorten this up. So I'm going to hop on this so it fits. We haven't had an angle being shared. So down here I have two overlapping triangles. One was in blue with that green peak, and one was in like a light brown with the green peak. They overlap in here in this brownish, bluish, whatever. It says these two triangles share this angle. Let's go grab an arrow and point at it. They both share that angle. Now I like to put an end at my arrow. And you know me, I like to make it bigger. When I'm talking about angles, I've been pretty consistent with being pink. So they both share this angle right here. If it is 80 degrees in one of them, it's 80 degrees in the other one. So I would stop and my brain would say, look, you guys share that angle up there. So I'm going to say, actually I think that last thing I copied and pasted was one of those. No, I didn't. Let's edit undo that. All right, I'm going to dump a little pink paint in that circle. I'm going to say that guy is the same in both of them. Now if you look on the blue one, I've got angle in green, this long side, double marked in brown, angle. And in the other triangle, I've got angle, side, angle. So I could stop and say new guy, angle, side, angle. We just got you, but our brain had to steal this missing angle up here. Why? Because it was shared. What reason do we use? The reflexive property. So this one says name the two triangles that are congruent by angle, side, angle. Well, it's pretty obvious that this one on the right, let's just go put a big red X in here, doesn't have any sides given to us, and we have no way of stealing any. So I know it's not those two, right? But when I'm listing them, so I know it's these two guys, but make sure you kind of see where you have your angle, side, angle. This one right here with KL only has two angles. So I would choose the single arc, walk the path to the double, go to the other one and go single arc, walk the path to the double one. So I'm going to stop and hit your text box. It's up there with a T. Which two triangles can I say are congruent? And I'm going to just use the word triangle. Triangle. The one on the left, I in any order, JH, but now I need to make sure I match my parts. I has two arcs, so I'll lead an L. J has one arc, so I'll go to K. And then lastly, I would go to M. Okay, so those triangles are the two that would be congruent by angle, side, angle. And again, you know, let's go bold and let's go white so it stands out nicer, and let's even maybe make it bigger so we don't have as much to clean up next week. Okay, we would say those are congruent by our new guy, angle, side angle. Well, you should know what's coming up next. Okay, a proof. This is number 5 on your worksheet. So at this point, you're going to pause the video, and it should have been at least 20 minutes into class. Otherwise, you were fast forwarding, and I'm going to ask you some questions. And you're going to come up here. You can work with somebody else if you would like today, as long as you're working well. But you are going to grab the worksheet, pause the video, go grab it, come back, and I'm going to talk you through number 5. I'm not going to be writing. Okay, well, I might type a little bit, but you're going to be writing it on your paper. So number 5 on your worksheet, and again, if you're watching this because you were absent, that worksheet's in the Schoology folder, says to do a fill-in-the-blank proof. I chose this one because we've got a new guy here, definition of perpendicular, so it gets a little funky in the middle. Okay, so first of all, I did what our workflow for a proof says. I put the given down, and I put that that BD is bisecting ABC. I'm going to grab that word bisect, and you should too. Circle it right here. I know what that word means. Okay, I'm going to arrange, and I'm going to move it back, send to the back. All right, oh, it didn't go. All right, well, you just go ahead and put that guy in a box. I know what that word means. Okay, so somewhere I'm going to be stating that BD, okay, look at it, from B to D, it's bisecting this top angle. So it's cutting it into 2 equal pieces. This one, sorry, I thought I had my bubble. So you can either go put a little dot or a little arc up at the top. I know that this angle up here boom, is congruent to this one right here. I'm having a hard time moving it for some reason. This one right here. Because BD bisected angle ABC. That statement is right here. ABD is the same as CBD. Why? Because it got cut in half. Why did it get cut in half? Because it says it bisects. So what did we say yesterday we put for that? I skipped to this one for a reason. Definition of bisect. I knew that had to be in there somewhere. They wouldn't tell me it bisected otherwise. Then they're telling me they're using the reflexive property. Well, I see 2 triangles butting up against each other right here on BD. BD, sorry, from B to D is exactly the same as from B to D. What is that? Reflexive property. So right in there for number 5, you're going to write BD, you're going to put a segment over it, is congruent to BD. Okay, those 2 you should be good with. You should also be good with the last statement because we always lead ourselves to what are we trying to prove. We're trying to get 2 triangles the same. Okay, and they're telling us to use angle, side angle. So this proof statement right here, you need to write it, watch the arrow, right there. So it seems like the only thing I need to figure out here is what statement 2 must have been. What does it mean to be perpendicular? There's 2 ways you can do that. You can actually do it in 1 step if you want, but this one's in 2. If I've got a perpendicular line, it means that it hits it at right angles. So I know that angle ADB and angle CDB are right angles. And again, why do I know that? Because I know what perpendicular means. And when that happens, we say definition of perpendicular. So now they're saying, well, those 2 angles have to be the same. Well, yeah, all right angles are the same. Sorry. All right angles are congruent. So I'm not quite sure why it's, there we go. So in this box, you're going to write all right angles are congruent. Okay, so they were obvious, but you haven't had to state that before. So the two new ones are right here in 2 and 3. They told me they're perpendicular. What do I know? I've got little right angle boxes down there. So the angles are right angles, which means they're the same because all right angles are 90 degrees. You could write that, or all right angles are congruent. That's fine. So that one's done. Now we're going to do not fill in the blank. So you should make the first statement. You should rewrite the given and put it right here. I'm not going to do that. Okay, and this next one, kind of want you to sort of think about it first. So pause the video and write down the given and write given. Okay, the next thing I'm going to do is make some observations over here. I asked in class yesterday for some observations, and on one like this, I think it was Reagan, I said, what do you notice about this? And she said, I'm seeing some parallel lines. And I said, yep, let's write that down. I see and am given. And then yesterday, I said, what is that a trigger for? And I think it was still Reagan, or maybe it was Royce, said, usually when we're given parallel lines, we get to steal some alternate interior. So I'm just making some observations. Yesterday we had one like this, and I said, what else do you notice? And I think Isaiah said reflexive property. And I said, what do you mean? And somebody said they share the segment GJ. Okay, well, I'm going to stop right there, and I'm going to go make some markings on my proof. I'm going to go like this. Okay. Also, for alternate interior, you can put double arcs in there on that transversal or that slicer. Again, I've been doing the pink dots just because it's really hard for me to make double arcs. I have to use a scribble tool. So I'm just going to go right there. This is what I call marking the picture. So I'm going to stop and repeat. I write down the given. Okay, I make some observations. I see parallel lines. I get to steal these alternate interior. The other pair was already given to me. I also see that they're butting up against each other, so I've got a shared side. Now let me walk the triangle and read it. I've got purple angle, side, angle. I've got purple angle, side, angle. I just got angle, side, angle. I know that's how my proof is going to end. So what you're going to do is you're going to go up here and you're going to, number 1, the given. Number 2, what did we notice? Number 2, I noticed the parallel lines. So I'm going to say angle FGJ. You're congruent to, when you're writing that, put the little squiggle over the top. The alternate interior down there at angle HJG. What's my reason going to be over here to the right? Alternate interior angle theorem. Pause and write it down. Number 3, what did I notice? They're sharing GJ. GJ is congruent to itself. Okay, now again, you should have the bar over the top and a congruent symbol over. I'm going to be walking around and checking that to make sure that you are listening. What's your reason going to be over here? When we share a side, we're reflexive. That's enough. I now get to stop. Boom. I have just proved. So you're going to have to write that down. Triangles are the same because I got my third reason of the chapter. The first one was side, side, side. That's not what I got. The second one was side, angle, side. That's not what I got. I didn't get 2 sides. I only got 1. I got the new one. Angle, side smash between them because it was shared, was the same, angle. Okay, so your job is to continue working on that worksheet, either alone or with a partner, but I will be walking around and I'm going to be checking that these were filled in properly. So have a good one, guys. You've been awesome.